So the problem is today is best time to buy and sell stock. Uh, I think this is labeled as a medium problem in LeetCode, but I think this is a pretty hard problem. I mean, I don't know because the problem called best time to buy and sell stock 4 has been labeled as hard, but for some reason the fifth variation, which is slightly harder than the previous variation, is basically labeled as medium, which I think is not correct, but anyways, that this is labeled as medium. Okay, so going ahead, let us read the problem statement and see what the problem wants us to find. You are giving an integer array prices where prices I is the price of the stock in dollars, and on the ith day and an integer k. Okay, so basically prices is an array, and then prices I gives you the price of the stock on the ith day, and there is another additional input called integer k, and then they're going to tell you what this integer k is. Here you are allowed to make at most k transactions, where each transaction can be either of the following. Okay, so k is the number of transactions, maximum number of transactions we are allowed to make here, and normal transaction buy on day one and then sell on later, where I so basically you buy and sell on a later date, and your profit is prices j minus prices I, which is obvious. And short selling transactions, so this is something new. I think from 1 to 4, from buy and sell stock 1 to 4, this short selling concept was not used, but in the fifth version the short selling concept is used. So what happens on short selling, we sell on day one and then buy back later on day j. So I think in the Indian stock market, short selling is only allowed intraday, that is you need to sell and buy in the same day. Can't keep uh, things which have shorts or stocks which have short sold for more than one day. I think probably in the options market is it is possible, but not in the not in the regular equity market. So anyways, so so obviously on short selling, how do you calculate the profit? Prices M and prices J, right? Because I you have I think I you have sold, and J you have basically bought. So this makes sense. Note that you must complete each transaction before starting another. That means that once you've sold, then you must buy to sell again, right? And then once you've bought, you must sell to buy again. That is what it means. Additionally, you can't buy and sell on the same day, and you are selling or buying back as a part of the previous action. So basically, selling and buying back on the same day, and the buying on the selling on the same day is not allowed. Anyway, that doesn't make any sense, because since the prices are basically constant in a particular day, which is not what happens in reality, but here for the sake of this problem, it is constant in a particular day. So anyways, buying and selling on the same day anyway doesn't make any sense. You'll get zero profit, right? So so that's also not allowed. Okay, and then return the maximum total profit you can earn by making at most k transactions. So this is the problem statement. So basically, or for this version, the new thing is you can also sell the stock and buy later, right? So let us see. So basically, if you look at the solution, I have used a DP to solve this problem, and I will explain you now that how do I, what do each of the indexes of the DP mean, and why have I taken it, right? So just let us directly jump into the solution, and then and as I go to the relevant parts, I'll explain you what they mean and why I've done them. So obviously I've stored the prices size in n for easy computation, and I've taken a 3D vector. The 3D vector, one of the indexes is n, which is the number of indexes in the prices. I mean number of days. So it can go to 0 to n minus 1. That is the first day till the last day, right? And then there is the second component of the vector, or the second dimension, which is k, which is of size k plus 1. That this refers to the number of transactions. So number of transactions can either be can range from 0 to k, which is k plus 1 numbers in the range. So that's why I've taken uh, this taken k plus 1 as the dimension of the second dimension, as the size of the second dimension. And then for the last dimension, I've taken 3. So here 3, what does it mean? So 3 means the indexes you can get with the dimension with this dimension of size 3 is 0, 1 and 2, right? So 0 means that we don't currently have not sold any stock and have not bought any stock. I mean, everything is evened out at this point. That is what 0 means. And then 1 means that we have bought a stock and then have not sold it yet. And 2 means that we have sold a stock and have not bought it yet. So that's why I have taken the number of the size of the last dimension as 3. Okay. Now after this, I'll go through some of the base cases, right? So this, I think, till here we have base cases. Let me write it down, right? And there, I think up till here base cases end. Okay. So I'll go through these base cases one by one, explain you why I have written them why I have written them this way. Okay. So the first line, if you go to line number 8, if so this is the line. Okay. So here, what does it mean? We are at zero index. Where is the first element? We have made one transaction, and then we are claiming that even after making one transaction, we are closed at this moment. That means we are not in a bought position or sold position, which is not possible, right? Because if it is the first element itself, you make one transaction, either you can sell or you can buy. So either you can be in state one or you can be in state two. You can't be in state zero. That's why these are invalid states. So I've taken int min here. Int min why I've taken here, because everywhere if you look at my I mean recursive computation, right? If you look at my recursive computation equation, then I always take max. That means if from somewhere a very low value comes, that will be definitely discarded. That's why to denote impossible values, I use int min. Okay. And then looking at the second base condition, this is obviously possible. So standing at the first element or first day, if I make one transaction and that is a buy, then obviously it is minus prices because we have to spend money to buy, right? And then if we decide to sell, then obviously because short selling is allowed, so basically we can sell on the first day itself without having without having a buying position before. I mean, without having the stock with us before, we can directly sell the stock, right? So that is what short selling allows. So obviously, since we have sold the stock, we'll write plus prices. Now we are filling base conditions here. So these base conditions are basically for x for I equal to 0. That means a day 0. For day 0, we are setting some base conditions, right? And then for day 0, we are setting base conditions for j equal to 2 to k. So this transaction from 2 to k we are taking, and obviously we know that we cannot basically do two transactions on a single day, right? That's not possible. We can only make one transaction, and that's the first day only. To till that point, we can't really make two transactions. So this entire thing will always be zero, no matter the index of the last dimension. We this sort of thing is always a possibility where the transaction count is greater than equal to 2. That's why all of those cases we assign them as intimate, right? So basically with this, for I equal to 0, everything is covered, so there is nothing left. So we basically set all the base cases for I equal to 0. Now we need to set all the base cases for j equal to 0. Why so? Because if you look at, I'll come to this later, but if you look at the main dp loop, like dp loop for calculating the entire dp bottom up. So the main loop, we start from I equal to 1, I equal to j, and then we have j minus 1 at some locations, and we have I minus 1 at some location. That means for I equal to 0 and j equal to 0, everything should be filled in order to make sure that while the dp runs, we have all the base cases required for populating the DP. While the DP loop runs, we have all the base cases required for populating the DP. Right. So I've already explained this. Now let me come to this. So this is what is this? When we have j equal to 0, that means no number of transactions. When we have no number of transactions, then we can obviously we can always be at state zero. That means we are neither buying a stock or not selling a stock. So that is valid. That is given by zero, and that we don't have to pay any price for that. So that's zero. And then for if we have done no number of transactions, we can't really go to state one or state two, no matter the number of the day we are on, right? So that means those are impossibilities. So that's why these two cases are assigned as intermediate. Okay, now that we have all the base cases with us, now let us go to the main DP calculation loop and see how and explain how those equations look like. So basically, in the main DP loop, our first index, which is the which indicates the day, will will uh, will loop from 1 to n minus 1, and the number of transactions would loop from 1 to k, right? So let us go through these equations, the main DP equations. There are like three sets of equations. I'll go through each of them and try to explain them. So what is this equation? So this means that we basically from the previous day, whatever position we are, we just carrying forward the position and doing nothing on this day. So we are carrying forward the position. If we are holding a stock, we are doing nothing. So we continue to hold the stock. If we've already sold a stock, we do nothing. So we continue to keep for the so the stock even for the next day continues to be in a sold position, right? So okay, and then we have if you're not holding a stock, then again for the next day, uh, we continue to not hold any stock. So this is why this is there. This is why this is there, and this is why this is there. So this is the bare minimum thing that we can do. One of the situations, one of the things that we can do, right? So this is handled by these three equations. Now coming to the next two sets of equations. First, opening a hold position. That means we did not have initially did not have a hold position open. We did not hold any stock, or we did not hold any sold stock or bought stock, but still now we are but at day ith we are doing that. That means if you look at this equation, so at day I minus 1, we had not like had any position open, right? But and then obviously we had one less transaction, and then at day I we are doing one more transaction, right? That's why day I becomes j. And then because of the transaction, since we are buying it, right? Since we are buying it, which is denoted by I here, we have to do minus prices, because buying basically you have to give money. So that is minus prices I here. And for the same thing, a similar thing for if you're trying to short sell, right? From a zero position, for a zero hold position, if you're trying to short sell, then obviously we have sold, so we have to add pluses plus I to this 2 dp I minus 1 j minus 1, right? Again I'm saying that this is j minus 1, and this becomes j because here we are initiating a new transaction, right? So j minus 1 becomes j. It is increased by 1. And now the last set of equations, DP equations, is when we are in open position and we want to close the position, right? So here, so you can if you look at this line, so we were at we have already bought a stock, and now we have sold this stock, and J doesn't change because we have already when we bought the stock, then already we included the transaction increase there itself. So now we are just continuing the same transaction. We don't need to increase the transaction number. So remains same, and obviously I we are basically comparing. We are basically on the next day. We are trying to compute the some DP equation of ith day based on the I minus 1 day. That's why I minus 1 is written here, right? Which is done in like all these equations, even on the top, all the other top two sets of equations, right? So for these equations, what we have done is we have basically sold a stock and the ith day, that till the I minus 1 day, that was bought position. So this is how the equation this one looks like, and this is the refers. So we have basically bought a stock which was on a short sell or short sell state in the till the previous day, right? Again, there is no j increase because while we initiated the short selling, we already incremented the transaction in then only, so we don't have to increment this again here. So these was our equations, and then using this we'll populate our DP. And now for the result, what does the result want? Our result wants us to give the maximum value which we can obtain by selling and buying, or buying and selling stocks right? Either buying and selling, which is the normal way, or doing short selling and then buying. Either of those way, after doing J transactions or J minus one transactions, or up to zero transactions, but that means the transactions at most J, how much, what is the maximum, what is the maximum profit that we can obtain. So dp n minus j 0 means that we have reached the last, we have reached till the last day, and then we have made j transactions. This j is obviously varying from 0 to k, which is the required limit as per the problem, right? And then for we are basically trying to take the max from what this value is, uh, for j equal to 0 transaction, j equal to 1 transaction, up to j equal to k transaction, right? And then we'll take the max across that, and then that will be our result, which is that, because that is the requirement of the problem, and then we return that. So okay, I think this was a very hard problem. It is because it is very difficult to come up with these equations. There are three dimensions to this DP, so that makes it hard enough. Though I've explained you very clearly, and now it should be very easy for you to solve this problem once you have seen the solution, and also understand the reason why behind every line of the solution. So yep, yep. So I think yeah. I think with this I've come to the end of this solution video. I see you in the next video. Thank you. Bye.